Students, welcome to my YouTube channel. Today we are going to solve quiz number 3 for the month of January 2025. A combination of questions from NET, NAV, Tech, Rex. So let's check how much we know about aviation and aviation theory. So question number 1. Which aircraft may be on a collision course? Aircraft on the right with red light inside. Aircraft on the left with red navigation light inside. Aircraft on the right with white navigation light inside. Let's solve this. Let's draw the diagram. So here, so this is your aeroplane. Okay, this is your aeroplane. It is flying straight ahead towards the North Pole. It is flying straight ahead towards the North Pole. Okay, now there are three options given to us, three possibilities. There are two aircraft on the right and one on the left. Now option A states aircraft on the right with red navigation light inside. So that means aircraft on the right with with red navigation light inside. So always there is red navigation light on the left wing and green navigation light on the right wing. So if there is aircraft to your right hand side, only the red navigation light will be visible to you. Okay, green navigation light won't be visible because it's on the other side. Next, there is another aircraft on the right hand side, but you are only able to see the white. I'm drawing blue color for white. You're only able to see white light of that aircraft. White light of that aircraft. Now, white light is situated behind the fuselage, on the back end of the fuselage, near the vertical stabilizer and horizontal stabilizer at the back, right? And then there is another aircraft which is on the left, and you are able to see the red navigation light. Now, red navigation light is on the left wing, So that means the aircraft on your left is flying in the direction of south. That means the aircraft on your left is flying in the direction of south. That is why you are able to see the navigation lights, which is the red navigation light of that aircraft. If the aircraft to your left were also flying in the north direction, you would have seen green navigation light, not red. Just because it is flying in the opposite direction, you are able to see red light. Now, out of these three aeroplanes, which one constitutes a safety hazard for you? Which one? So, the one with white light visible to you, that means it is flying away from you. It is flying away from you. Okay, that's why the white light is visible to you. The one with red light on your left is flying away, is flying in the opposite direction to your flight path. That means it will not collide with you. It will fly in the opposite direction and go away. The one which is of interest to safety is this aircraft. Now this aircraft you are able to see red navigation light. That means it's either it is flying along with you, or you both are converging at one important point, at one significant point, or some VOR station somewhere. Okay. So out of these three aircraft, this aircraft is of danger. This one is going far. This one is ahead of you and going away from you in the same direction. This one is going in the opposite direction. But this one, he may be flying along with you straight up, okay, somewhere around in your neighborhood, or it may be converging or crossing your flight path. So this aircraft is of danger. So aircraft on the right with red navigation light inside is dangerous. Question 2. The highest point on the ground in an airfield. So your airport, your aerodrome, your airfield. Now not the entire airfield will be a plain level ground. Somewhere it will have high elevation, upslope, downslope, like that. So out of all this, the elevation of the airport will depend on the highest point on that ground. So you have this entire airport. Some part of this airport will have high elevation, some will have down elevation, down slope. So what will be the final elevation of your airport? Will you take the consider elevation of your airport which has a down slope or up slope? So according to the law or according to regulations, ICAO, the highest point on the airport or the highest point on the airfield is considered your airfield elevation. It's considered your airfield elevation. Okay. ARP is your aerodrome reference point. ARP is your airfield reference point. That means your airport may be very large in size. Okay, out of that entire airport, we take one point on that airport, which is the official location of that airport or designation of that airport. We call it aerodrome reference point. And you can see the airfield elevation, airport elevation given on airport charts, airport flight directory charts, approach charts. Okay, airport elevation is always mentioned. So that airport elevation is the elevation of highest point on that ground. Remember that. Question 3. In a piston engine, when is a large mass of air pushed and at what velocity? So there are two types of engine, piston and jet engine. In case of piston engine, a large amount of air is pushed backward at small velocity. In case of jet engine, a small amount of air is pushed backward at large or very fast velocity. So remember this point. Okay, it can get asked in any exam. So in a piston engine, a large mass of air is pushed rearward at low velocity. A large mass of air is pushed rearward, that is backward, at low velocity. In jet engine, a small mass of air is pushed backward at fast velocity. Next, question 4. Which is a characteristic typical of a stable air mass? Okay, stable air mass. Now, air masses can be stable. Atmosphere can be classified as stable or unstable, depending on the heating of the ground, temperature, lapse rate, etc. etc. So, characteristics of stable air mass is continuous precipitation. The option Charlie is the correct option. Now, cumuliform clouds and showery precipitation are the outcomes of an unstable atmosphere. Are the outcomes of unstable atmosphere. So what happens? This is your land. Let's say this is your land surface. This sun in the atmosphere. And the insolation of this sun will be received by the land surface, right? The insolation of the sun will be received by the land surface. As a result, this land will get heated up. This land will get heated up during daytime, and as a result of that, a low pressure will be created. A low pressure will be created over it. What is the outcome of that low pressure? The low pressure will result in convective currents. The low pressure will result in convective currents in the atmosphere. This convective currents when rise in the atmosphere, convective currents is nothing but air current, parcel of air which is rising in the atmosphere. As it rises in the atmosphere, its volume increases, temperature decreases. At some point of time, the temperature will cool down enough to saturate it, and below freezing point it will condense. So we will have, when condensation happens, we will have development of clouds. Now, if atmosphere is unstable and temperature lapse rate is very steep, so what will happen? This convective air currents will develop more strongly, and they will start lifting this parcel of air or parcel of cloud higher and higher up in the atmosphere. As a result of that, the size of that cloud will also grow, will also start increasing, growing in size. And these clouds in the developing stage are called cumuliform clouds, cumulus clouds. And when they keep growing and growing in size and area, they develop into a mature stage called cumulonimbus clouds. Okay, so any cloud like cumulus cloud, cumulonimbus clouds, these clouds give you showers. Okay, showers is nothing but a precipitation, but of very higher value, higher than continuous precipitation. Okay, so continuous precipitation, okay, when it increases in magnitude, we call it shower precipitation. And showers, cumuliform clouds are the outcomes or products of unstable atmosphere. Opposed to that, continuous precipitation is an outcome of stable atmosphere. Now, in stable atmosphere, what will happen? The lapse rate will be very mild or will be very shallow or very slow. As a result of that, the parcel of air will not get lifted very high in the atmosphere. It will be limited to the lower rungs of the atmosphere, and it will stay there. Okay, and such clouds which are the products of the stable atmosphere are nimbostratus, low level clouds, and these low level clouds are known for giving drizzle or continuous precipitation, but not showery precipitation, which is much more intense than drizzle or moderate rain or continuous precipitation. Okay. Next, what feature is normally associated with cumulus stage of a thunderstorm? So there are three stages of a thunderstorm. Cumulus, that is the beginning stage, the starting stage, the incipient stage. The second stage is your mature stage, that is when the cloud is fully developed. And the third stage is dissipating stage or dying stage, when the cloud comes to the end of its life cycle. Okay, so cumulus stage is the first stage of the cumulonimbus or thunderstorm cloud. And in this cumulus stage, you have predominance of updrafts. At mature stage, you have availability or presence of both updrafts as well as downdrafts. Okay. In the dissipating stage, you only have downdrafts. You have predominance of downdrafts. So remember this. So cumulus stage is continuous updraft. Okay, continuous updraft. Beginning of rain at the surface is a sign of mature stage of thunderstorm. Question 6. Assuming a 5 dot display, what does each dot on either side of ILS localizer cockpit indicator represent? Now the maximum deflection on ILS localizer instrument that is allowed is 2.5 degree, 2.5 degree left or 2.5 degree right. Now one dot be equal to what value in case of 5 dot indicator? In case of 5 dot indicator. So the maximum deflection is 2.5 degree. And how many dots we have? 5 dots. So if 5 dots represent a maximum deflection of 2.5 degree, one dot will represent how many angular deflection? Cross multiply 2.5 divided by 5 is 0.5. So remember this. In case of 5 dot display, 1 dot equals to angular deflection of half degree. In case of 4 dot display, 1 dot will represent angular deflection of 0.625 degree. So correct option is option A. Read the question carefully, whether it speaks of 5 dot display or 4 dot display, and then pay attention to the instrument, whether it's localizer they are talking about or glide slope. Okay. Next, suction system of aircraft can provide the source of power for what? So the suction system is your vacuum system, and there are three gyroscopic instruments: attitude indicator, heading indicator, turn and slip indicator. So out of these three, the first two, attitude and DGI, heading indicator, work on vacuum. So suction system is used as a source of power for gyroscopes. Okay. Altimeter is a pressure instrument. Pitot static instrument are also pressure instruments. So option Bravo, Charlie and Delta can be eliminated. Question 8. Which direct picture does the attitude indicator display? So this is your attitude indicator. Now this attitude indicator can be used to determine attitude of aircraft. What is attitude of aircraft? Attitude represents the relation between the nose of your aircraft and the horizon and the horizon. That is called attitude. Okay, now in this case, the attitude of aircraft, that is the nose of aircraft, this dot, orange dot, represents the nose of aircraft. These two horizontal bars represent the left wing and the right wing respectively. Okay, so now in this particular image, this example, your aeroplane is flying straight and level. Okay, straight and level with the horizon. In case it's climbing, when aircraft climbs, this horizontal bar and the center dot that represents the nose of aircraft will rise above the horizon. So this represents a climbing attitude. In case of descent, that aeroplane symbol will go below the horizon in the brown shaded area. So brown area is your ground, blue is your sky. So during descent, your attitude of aircraft will be towards the ground. So this is your pitch down attitude. So answer is, which picture does the attitude indicator display? It displays climbing attitude, it displays takeoff attitude, it displays descending attitude, it displays aircraft attitude. So the most appropriate option will be delta. Aircraft attitude. Now aircraft attitude can be descending, straight and level, and ascending. Okay, so it can represent any one of these three. Okay, so it displays aircraft attitude, any aircraft attitude. So with this question, we have come to the end of this lecture. I hope you have understood these questions, the concept, the understanding behind every solution. You learned something new today. Like this lecture if you have liked it. Subscribe to this channel if you haven't yet, and share this video with all your friends and colleagues. Keep learning. Don't miss the next video. See you soon.